First, I will talk through some slides before I start the demo. This figure is about the data flow for how we translate the data and what we do with the data. NAXT, our solution, is on the left. We take information like historical data and upload it to what is called the Azure Blob Storage, which can handle huge amounts of data. We upload this data using a periodic job in NAXT, which I will show you in the system. And then the Microsoft R server is going to take care of consuming the data. Each dealer has its own instance of NAXT and its own blob storage. The Microsoft R server takes care of merging data from each of the dealers or sources and then publishes it to the Predictive web service endpoints. Now, this is something the dealer can opt out of, but the benefit of merging the data with the other dealers is there will be more data to be considered and used for training the model for both of the web services, a contracts web service, and a follow-up notes web service. The web services are how we consume that data into NAXT. Now, the first scenario I'm going to run through is around service agreements, or what we call service contracts in NAXT. There's an opportunity to sell a maintenance contract to a customer in NAXT in order to create a quote for this. I will start by estimating those costs and margins on the contract, then create and send the quote from there. The goal in this scenario is to estimate the costs involved in this contract and try to offer the customer a good price while also collecting a healthy margin for the dealership. So I'll begin by reviewing the functionality we were working with previously, which are the base plans in standard jobs. Base plans in standard jobs allow us high-level visibility into the cost estimations on the service agreements to gather base plans in the standard jobs to find the services that need to be performed on the equipment, specify how often we need to do these jobs, what parts we will use, and how much labor it'll take. This information is based on the standard instructions from the manufacturer. Now, to support more exact cost calculation, we extended and enhanced this current functionality with R-based machine learning and predictive maintenance. We call these enhanced functions smart calculations, and they will check the maintenance path that was provided by the manufacturer, but more importantly, it'll take into consideration event history, service history, usage history, and look for patterns in that historical data. The patterns allow NAXT to come up with a more precise expected total cost. So now the salesperson has the ability to consider the new calculation and then provide a more appealing quote to the customer while still collecting that healthy margin for the dealership. The second scenario is based on follow-up notes on service calls. Follow-up notes are used in NAXT in relation to machine failures and possible failures. So in this case, we have machines in our population which are monitored by sensors. Now, we'd like to get information from those pieces of equipment, like knowing when they will break down before they break down. This way we have a chance to warn our customers, so the idea behind this second machine learning function is that it'll provide better customer care and additional repair revenue for our dealers. So, just like in the last example, NAXT consumes these predictions that are calculated by machine learning. And in this example, it consumes this data via a periodic job, which creates follow-up notes for pieces of equipment that are going to fail in a specified time period. The periodic function would typically run every night, so that in the morning, the new follow-up notes that were created work as an alert to the service manager or service clerk, whoever would be responsible for calling the customer and letting them know about a possible issue. This way, they can ask the customer if they would like to schedule a service. So that's how this function works to provide better customer care and additional revenue for the dealers. The first thing to mention is that the service module is a NAXT module. I want to begin by showing you the periodic function we were talking about that uploads that historical data to the Azure Blob Storage. It's located under Periodic, Machine Learning, Training, Data Upload. A query is run in the system based on what we have set for the parameters, and then that historical data is uploaded to the blob storage where the machine learning experiments are able to consume it. The more data types we choose here, the more accurate the predictions will be. And this is meant to be set up as a batch job, or you can specify one that should be executed, the occurrence may be daily or overnight, and then the system will do it on its own. So this is meant to be set up once and then added to a batch job, and the system will take care of it automatically. The first scenario is around contracts, so I'll come up to the All Contract web page. For demo purposes, we've created a contract here that I'll open. So there are two parts of a contract, the header and the lines. On the header, there's customer information and date information. On the lines, we see that this contract is covering two pieces of equipment. We'll have two different equipment IDs here, and two serial numbers. Each piece of equipment is being covered from August 1st to December 31st. I can now open our quote builder. Something that's important here is our base plans. This is what I mentioned before. It contains standard jobs and standard job groups. So this is what tells me exactly what services need to be performed and what resources will be needed to perform them, so labor and parts. Once I have that set up, I can click this Generate button here. That's when these numbers would populate. We're looking at the totals for parts, labor, miscellaneous, our overall total, and cost per hour. If I want more information from where these costs are coming from, I can scroll down to the line details. I can see that there are two standard jobs listed here. Each are scheduled to occur twice during this contract period. Then we have the parts, labor, miscellaneous, and a total split out for a standard job. We can continue scrolling down and see more transaction details. This is where we see the actual part numbers or how much labor it'll take to accomplish these standard jobs. Now, these calculations are being based on the manufacturer's standards. But where we've enhanced this functionality is our smart calculations here. Once I press this button, a live call is made to the web service that's published in the machine learning endpoints. And now the smart calculations are executed and will be populated based on the data we've received from the web service. So this is machine learning data we have published here. As we take a look at these numbers, we notice that they are a lot less. They're actually half as much as the totals listed above. So if we take a look at the details below, we can find out why. We also have smart fields listed on the line details, one of which is the smart occurrence. So you can see that based on the historical data and the predictions that were made, these standard jobs will only need to be executed one time each, versus the two that were defined by the manufacturing standards. So the important fields on here are those smart quotation fields. And at this point, the normal CRM process would resume. The salesperson can actually create a quote from here, and all this information will copy onto that quote, and they can send it to the customer. If the customer accepts, then we can activate this contract. This second scenario will be around follow-up notes. This is a list page that collects all of the follow-up notes. In previous versions of our software, follow-up notes could be entered manually, like, for example, a field technician when they're out and find something on a machine that they're working on that doesn't require immediate attention, but will in the near future. So they would make a follow-up note for that piece of equipment for their service managers to follow up with the customer on a later date. Now that functionality is still available, because it's obviously still important to have. But we've extended that functionality to a periodic job, which I will show you now. Called Create Predictive Follow-Up Notes. With this periodic job, a call will be made to the machine learning web service and create follow-up notes for each of the machines that will fail in the next 45 days, with the probability of at least 96%. This periodic job can also be set up as a batch job, so it can automatically be set to run every night, so that every morning, the new follow-up notes are waiting for the person and service that's responsible, and they can call the customer and schedule a follow-up service. If we go back to our follow-up notes list page, there should be some new follow-up notes that were created. These new follow-up notes can be added to a role center or a landing page, so that when the people are signing in for the day, this information will be available on their welcome screen. They don't have to necessarily go to this list page and search for these follow-up notes. We can use them as alerts as well. So you can see that we have some smart fields available here, and these are being populated from the machine learning web service in Azure. So this is machine learning-based data. As we can see, this machine, this equipment ID here, this make and this model, it looks like it's going to have a problem with its electric drive. It's scheduled to have this issue estimated at this SMU. It's estimated to reach this SMU reading on the date here with a probability of 96%. At this point, we would call the customer, and if the customer approves, the service manager can create a new opportunity, maybe a new activity, or a new service call from here, and all of this information will be populated onto one of these new forms. And that is the predictive maintenance functionality within NAXT.